think we're going to integrate from and to? What are our limits of integration?
0 to 0.
It's 0 to 5. What do you think we're going to integrate here? Well, delta x times the square root of what? 1 plus what?
F prime.
What is f prime in this case?
3x squared.
Oh, look at that. Is that oh, what is delta x? What's another way to write delta x? Dx. Hey, that is the arc length of the curve y equals x cubed from 0 to 5. No, that's exactly it. That's literally it, because what do we know about Riemann sums? As n goes to infinity, it approaches the actual number. Here's the only thing, two things I want you to remember. Arc length, really straightforward in Cartesian length. In parametric. Is this an integral you want to do by hand? No. Say no. Just say no. Frequently, when I give you arc length questions, you are going to need your calculator or a lot of time if you don't have your calculator, or it's really straightforward. This is not a nice integral to do, but it's something you will definitely do on the AP exam. They love to ask you things like set up but don't evaluate the integral, and then they'll give you five integrals that look very similar. Very similar. Again though, this is not parametric, this is in what? What coordinates? Cartesian. You have to have it in y equals form. How does it change though? It changes like this, and it's very, very, very similar. This is very similar, but we're dealing with what type of equation? Parametric equation. To find the distance between 2 points, we used what type of triangle? A right triangle. What was the base before? Delta x and delta y. Now it's going to be dx dt, the horizontal rate of change, and dy dt, the what? Vertical rate of change. What do you do with the base? You square it, and then you add it to the square of the height. What is this right here? The base squared, and what's this? The height squared. And what do you, square rooted? A to b. What type of values are a and b? T values. T values. So if you have a parametric curve, what can parametric curves do, by the way? A lot, right? Can they do weird curvy stuff? Can they go in circles? Can they repeat themselves? Can you have a track that, remember the unit circle you were doing before? Can it go around an infinite number of times? So when you're doing the arc length, generally speaking, what do you think the hardest thing is to find if it's not given to you? The derivatives are usually really easy. The a and the b values. Kids mess up the a and the b values all the time. Let me show you what I mean. Let's make one up here. What was this? What was x equals cosine t and y equals sine t? What was that? That's a unit circle, right? Let's say I wanted to know what's the distance around the circle using this formula, the distance around the circle. What's one rotation? How far? How much time does it take to go around one rotation on this? Where does it start? T equals 0 to what? 2 pi. Okay, so what integral would we need to integrate here? The integral of what? 0 to 2 pi of the square root of, well, what's dx dt? Negative sine t what? Squared plus cosine t what? Dt. Right? Everybody with me so far? Well, what's sine squared plus cosine squared? So this is just the integral from 0 to 2 pi of what? Dt. So what is that? It squares. It becomes positive when you square it. So what is that? That's just t from 0 to 2 pi, which is what? Is that the circumference of a unit circle? So it worked in that case. What happens if I had changed this and said, oh, it's 3 pi? What's going to happen? It's too much, right? Many of the questions you're going to do, it's going to tell you the limits of integration. This looks visually terrible. Is it that bad? No, it really isn't. But again, this is parametric. The other one is what? Cartesian. Parametric and Cartesian. Okay, so is that a circle? No. What's the one number in there that messes it up? 2. The 2 messes it up. What does it turn it into? An ellipse. Now you might, if you wanted to make this into a Cartesian equation, what should I do with both of those? You've done it a bunch of times already. What should I do with both x equals 2 cosine t? If I wanted to translate this into a Cartesian equation. We love squaring and adding, right? We love squaring and adding. So what do you have here? X squared is equal to what? 4 cosine squared t. And then what does y squared equal? Equals sine squared t. Well, this means that cosine squared t is equal to what? X squared over 4. So do you see these two right here? What can you do with them? Sine squared t plus cosine squared t is equal to what? Y squared plus what?
X squared over 4.
What is sine squared plus cosine squared? 1. So do you remember your ellipse equations? Is that an ellipse?
Yeah.
We just proved that it's an ellipse. We just proved it. So if we wanted the circumference, what are we integrating from and to? Oh, does it tell us what we're in? Look in the upper right, everybody. Does it tell us?
Yes.
You love it when they tell you that, because on the AP exam, they're not always going to tell you that. You're going to have to remember it's 0 to 2 pi. It will change, though, because look, what happens if it was 2t and 2t right there? It would go from 0 to what? Pi. Will they give you answers that correlate to 0 to 2 pi? Uh-huh. Be very careful. So, Ian, what's the expression? It's going to be 0 to 2 pi of what? Of the square root of what? What?
Dx over
Yeah. dx, dt. Yep. dy, dt. That's fine. Squared.
Yeah.
So what's that going to be?
2y.
2 what?
2y. Oh.
What's the derivative of x? 2 what? dx, dt. It's right there. What's the derivative in terms of t?
Oh, so negative 2 cosine.
Yeah, negative 2 sine t squared plus what?
Cosine
Cosine t what?
squared.
dt. Now, this one right here, is this something you want to integrate by hand? Why not? That 4, right? You really don't like that 4 that's going to pop out right there. So what are you going to use if I ask you for this? You can use it, well, if you did it by hand, you'd have to do a crazy substitution, or your calculator, or then you can remember how to find the area of an ellipse. Do you remember what the formula is for the area of an ellipse? How many radii does, how many cardinal radii? There's 2 of them, right? There's the short one and the big one, right? So this one has 2, you average them, and then you multiply them together, you multiply them together and multiply by pi. Okay, it is 10:20 now. Get to your next class. Thank you for your attention.